I'd like to welcome Job Snyders. He's going to talk to us about peering automation that he's done at his network called ColoClue.
Thank you. As some of you might have suspected, in my spare time, I also work with networks and BGP and routing. This is who I am. Let's see. So the green button. Oh. I'm going to talk about automated peering operations at ColoClue. ColoClue is a very, very small hobby ISP based in Amsterdam. It's a non-profit association, and it was initially started because people traditionally would host their personal server at their employer. But if you switch jobs every 1 or 2 years, then you need to fight with your employer to get your server back and renumber your IP. So a bunch of network and system engineers thought, hey, let's do our own co-location thing, and ColoClue was born. We're 100% volunteer driven, there is no paid staff, and ColoClue doubles as my personal BGP experimentation testbed. As you may imagine, I cannot just deploy anything in NTT's network. It would not be appreciated by the management. But at ColoClue, uptime is an optional thing. There is no SLA, there are very low expectations. So this is where I do the kinky stuff. We're one of the 3 networks on the planet that do actual RPKI validation. We are 1/3 of that group. We were the first ISP to deploy large BGP communities in their routing policies, and there's a whole bunch of milestones that we have crossed. ColoClue's network pushes through, say, 100 megabit, so traffic-wise, it's not very impressive. But we are present at 2 internet exchanges, AM6 and NOIX, and the totality of V4 and V6 eBGP sessions is almost 1,000 sessions. Our router configs are roughly 51 megabytes because I'm doing kinky things, like there's a full RPKI database in there, and we generate strict filters for every eBGP peer. So what are automated peering operations? When 2 networks like each other, and the computer will consult PeeringDB to figure out where they can interact with each other. The computer then uses various data fields from PeeringDB that will later on influence the specific configuration for that particular peer. It will set up eBGP sessions to all of the IP addresses listed on the common internet exchanges. And if for some reason an IP address disappeared from the PeeringDB record, then the computer will clean up the sessions to the IP address that was formerly in use. And this process is run every 11 hours or so to ensure that the data in the network is fresh. Why would you automate these peering operations? The first big reason is to avoid coordination between humans. And in the next slide, I'll delve deeper into what that exactly means. By outsourcing these tasks to the computer, we also reduce the risk of discoordination. For instance, when I talk to one of you and we agree to peer, and then later on we discover that when he said NOIX and I said NIX, that we were actually talking about different internet exchanges. All of this coordination can go wrong if you allow humans in the process, so we remove them. And secondly, ColoClue is a very diverse association. There are 110, 120 members or so. Some of them are programming experts, some of them are system administration experts, and some of them are networking experts. And when we were offered to connect to the Amsterdam Internet Exchange and the NOIX, I feared that if my enthusiastic co-members would log into the routers and would, start configuring eBGP sessions, that it may result in embarrassment for our association, because a small typo can result in route leaks or whatnot. So I figured if we automate this in a foolproof way, where at multiple layers of the process there is validation whether this makes sense, where people do not immediately have access to the things that can make disasters, then everybody can set up peering sessions, but they wouldn't risk the operation of the association. And on the topic of human coordination, nothing is worse than somebody that is peering at the internet exchange, fee4 only, and then has to email everybody, hey, we enabled v6, can you add the v6 session as well? At NLX and M6, there are hundreds of networks. So if you have to coordinate with them through this unstructured data called email, it's a waste of everybody's time. Furthermore, if a network adds a second or a third connection to the internet exchange, do not email me. I don't want to know. Let the computer know, enter that data on PeeringDB, and our system will just automatically pick that up. And subsequently, if you remove one of your IX connections because the migration is finished or you're deprecating the platform or whatnot, do not email me. I don't want to know. Just remove the entry from PeeringDB and my system will follow. And this is a huge time saver and therefore a money saver. A little bit of human element remains in this. For instance, it's still humans that have to agree with each other. We will peer with each other. But that is usually a very brief conversation. Another human aspect is that most peering agreements are not computer parsable, let alone human parsable. But you still need to ensure that the expectations of one party and the other party actually have some overlap and that a peering can be set up. And lastly, troubleshooting. The computers just drive the configuration, they push it out to the routers, but they don't actually have debugging capabilities. So if a session doesn't come up for whatever reason, a human needs to log in and look at the syslog or the show BGP neighbor outputs. So what does the practical workflow look like in the case of ColoClue? When two networks love each other, one of them can submit a GitHub pull request to update a particular text file that represents our database. We purposefully used a text file to make it easier for people to understand what is going on and to ensure that all the data that is used in the entire process is actually available for people to inspect. Because if you look at source code and there somehow is a magic query to a database, but you don't have access to that database, then it is less educating compared to having absolutely everything on GitHub. If the peer doesn't want to do GitHub, then one of the ColoClue volunteers can update the file on GitHub. Once that's merged in the master branch, a process is kicked off that is governed by an open source tool called Jenkins. Jenkins is often used for continuous integration, but in this instance, Jenkins is our provisioning engineer. Jenkins kicks off a script called update routers, and that's it. The reverse process is just as simple. If we want to depeer somebody or somebody wants us to depeer them, you just remove the relation from the text file and new configurations are generated and pushed out. This is an example of our backend database. It's just a flat YAML file. At the top level, there's keys that represent the autonomous systems, and under that top level key, we have various data fields, such as a description, which AS set to import, what we will export to them. This way, we can also configure downstreams. Then we'll configure, instead of export ColoClue, we'll say export any. And as we go along and discover that certain things cannot be retrieved from PeeringDB, we add new key value thingies or features to the YAML parser. Why this works is, like with many reasons for network automation, the there is only a single source of truth, and the database is authoritative. If any of the volunteers would log into a router and configure something manually, that's fine, but within a few hours, the computer will just crush that custom manual config and replace it with something that was coming from the automation system. Another aspect is idempotency. The deep peering works because every time we generate full configs, 100% of the BERT configurations is generated by the automation system, and you can run that script as many times as you want. It will result each time in the same output. And humans are really, really bad at repeating tasks. Fortunately, computers do not mind that as much as we do. For further insights or inspiration on network automation, click the link from NANOG a few meetings ago on do's and don'ts of network automation. And a lot of those principles have driven this particular system. This is probably not as readable as I hoped it would be, but this is a small example of what the system does. It's basically Jinja 2-driven templating, and in those templates we fill in variables that come from the YAML file or that come from PeeringDB. And the system merges all the data sources, runs it through the template, and out comes this 51 megabyte BERT config. All of this is on GitHub. We call this system Case, which is a very, very old-fashioned traditional Dutch name. It doesn't have any meaning though. This software is not something you can just clone and deploy in your own network. The reason I put it online is just as a proof of concept or demo. This is one approach to automate peering operations. It does a little bit more than just the peering. It also helps set static routes to the members of the association, or it helps arrange BGP sessions with people that are downstreams of ColoClue. And then the second piece of open source that is interesting is from the eKicks guys. They worked on a nice looking glass that interacts with our BERT routers, and that shows our peers if routes are rejected for some reason, why those routes are rejected. For instance, is this an RPKI invalid route announcement, or is an IRR entry missing, or is there a bogan ASN in the path, or any of the same sanity filters that we apply to eBGP announcements are identified as causes for rejection, and we make that visible to peering partners. So there are a number of considerations when you automate peering operations like these. For instance, I assume that my peering partners will want to peer with me at every internet exchange that we have in common. This may not be true. Maybe a peering partner expects that we will only peer at that internet exchange regardless of any other internet exchanges that we have in common. So how do we handle that? In this case, ColoClue will just send SYN packets to the peering partner at the internet exchange where they didn't want to peer. And that's that. Some people say, well, we should use BGP sessions to steer where traffic flows, but on the other hand, you might as well argue that you should use traffic controllers to steer traffic and not the construct of a BGP session itself. What this software tool doesn't do either is validate whether people actually adhere to whatever peering agreement there is. For instance, if we agree to do consistent announcements on all internet exchanges, that may well be, but the software does not verify this. MD5 is a challenge. I love publicly accessible data, but apparently you cannot just publish the secret passwords, and people will freak out if they see the secretly negotiated password in our public data. So how do we handle that? Should maybe PeeringDB have a feature that we can exchange secrets with each other where it functions as a clearinghouse, or should we have some automatable email format? Or I don't really know how to solve this one efficiently, so MD5 still requires some manual work. And what do we do with sessions that are down? Should we just ignore them as long as some sessions are up somewhere? Or should we proactively inform PeeringDB, hey, this IP address is listed under that participant, but we haven't seen an ARP entry or an IPv6 neighbor discovery entry in 2 months? Or should we have some email format where we can negotiate with NOCs when we see a session is done and we expect action from you? This is still an unanswered question. This brings me to the end of my presentation. With it, I would leave some questions for you, like, is this an interesting concept? Will you do it as well? How can I help you? And perhaps you have inspiration what we can do differently. Credit where credit is due. Ren Provo was the one that inspired me to build this in the first place. So it's not even my own idea. I thrive on receiving feedback from you guys on what we can do differently.
Hi, I'm Patrick from Markley. First of all, awesome stuff. Thank you very much. I noticed in your YAML file you have lots of information that you could theoretically glean from the PeeringDB. Why isn't the YAML file just a bunch of ASs that you agree to peer with, and then you get the rest of it from open source, IRRs, PeeringDB, et cetera, et cetera?
You're right. There is some data duplication, and this is an ongoing process. The YAML file first was extremely descriptive in that it covered every aspect of BGP sessions, such as the IP addresses, and then step by step, I remove data from the YAML file and add a feature that retrieves it from a data source. So this is something I do in my spare time, and you're basically seeing something that is a work in progress. But you're right, there's much more data that I can get from PeeringDB itself.
Matt Petak from Yahoo. Answering Patrick, if you've ever actually tried to do automation from PeeringDB, Patrick, you would discover very quickly the number of people who actually update their prefix counts and useful stuff like that is way, way small. And the amount of time that the humans end up sending out email saying, could you please go to PeeringDB and update your prefix count? You keep popping the session limit. I understand entirely why he's putting overrides in there.
Well, and to add to that, the construct of maximum prefix as we use it on PeeringDB, what are the actual semantics? Is it the amount of routes that I will announce to you, or is it the desired maximum prefix limit setting on your site? And those two values, there's a big, big difference between them. So I think this is something for the PeeringDB community to figure out, like, what do these values mean? Is it a desired filter, or is it a statement of what I'm doing?
Hi, Chris B. from IBM Bluemix Infrastructure Software. Any thought, instead of just leaving the peering session enabled if it's down, rather tear it down and actually have human intervention happen like afterwards, so there's not extra broadcast traffic on an exchange?
Yeah, but on the flip side, the broadcast traffic is statistical noise. I mean, the few SIM packets, of course, on these routers, we set specific ARP timeouts so that you do not constantly query. And most of the routers do this pretty well out of the box. But does it really matter?
I mean, if there's larger adoption and a lot of members using this, and then a lot of members maybe not following up and actually getting things configured properly, like people who aren't running it, maybe it could be a problem. And I've seen some exchanges kind of get a little grumpy if you were leaving sessions up and the partner isn't there anymore. So just a thought.
Thanks. All right, I'll be here the next few days, so if you have further questions, hunt me down and we'll talk. Thank you for your time.